Good morning, good afternoon, everyone. Welcome to Open Science with OHDSI. My name is Kees from Bochove, and today I would like to take you through the question of how do we generate medical evidence in a reliable way? And in order to set a context for why that would be an important question to ask ourselves, let's travel back for a moment to March this year, when the coronavirus pandemic was at a peak across the world. And we saw that scientists all over the world rushed to understand the disease and try to generate evidence on what may increase or harm the progression, what is beneficial. So for instance, we had this report coming out that ACE inhibitors may increase the risk of COVID-19, but then people were sharing things on LinkedIn like, well, actually, the angiotensin receptor blockers, they may be beneficial. And then even a week later, you see the same UREC alert channel saying that now evidence suggests that ACE inhibitors may actually improve the prognosis. So clearly, this was a high topic of interest at the moment. And what I would like to show today is that open science can help in these kind of times to generate reliable evidence. So just to give you a bit of background before we go into that on myself and my company, the Hyve, my training is in bioinformatics and computer science, but I've always been fascinated by open source communities in particular, and by open science. And so the Hyve, as a service to our customers, we enable open science and we implement open source solutions, and we also help with data verification. You can see the team as it is currently, or actually a few months ago before Corona times. And you can also see some logos on the bottom of the open source solutions, and one of them is OHDSI. We operate in a ecosystem of partners like Custodia Alliance, GoFair, and we also participate in many pre-competitive projects, such as IMI projects. I'll show you again one example, which is EHDEN in this talk. All right, so as said, I want to say something about open science, and I want to make the case for medical evidence generation through open science, starting with why we care about this. I want to show that it's changing, and I will also illustrate that with a concrete example of the OHDSI COVID-19 studyathon. So first of all, why open science? Let's see if we can dive into this a bit further. I would like to make the case that science as we have it today is quite broken in several ways, but also that it can be fixed. And one of those aspects, just to quickly go through some of them, is that the career path is really providing some incentives almost for bad science. So here we can see some numbers on the differences in the number of postdoc appointments in the United States, how they went up in absolute numbers over the year. And look at the salary difference there. So what this means is that a postdoc, another word for it is, you could almost say cheap labor. And I found this blog post that perhaps slightly romantically, but still I think there's some truth in this, that it used to be the case that a PhD student had at least a shot at becoming faculty. But if you look at the situation now, it's very hard to make faculty. There's simply not enough positions. And so what you get is this eternal cycle of being a postdoc and trying to get there with many others on those positions. And you can see a parallel effect happening in journal publishing, where journals used to be a medium for discourse, for the scientific discourse, just as a support for conferences, for instance. But today we know that if you want to publish your article, it's more like a race to get into one of those top tier journals. So what that leads to is sometimes very hasty science in the best of cases, and sometimes even outright fraud as well. But it says something, I think, that over the last year, the second highest cited article across all of science, according to Altmetrics, was this paper, where a number of scientists call for the retirement, so completely abolishing the term statistical significance, because it's so much misused and misinterpreted. And yeah, we could have a talk about that, but I'll just leave it there. The last example I would like to give on where science is breaking down is that a lot of data is not fair. And one of the people that maybe has illustrated this best is one of my mentors and someone that got me interested in this topic in the first place, Barend Mons. And in this book, he created a number of pictures. This is one of them where you can see that the data is essentially buried in this silo, graveyard, whatever you want to call it, of supplementary data. And in my talk yesterday, I said a lot more about that, so I'll leave it at this. So what do we need to do in order to fix this or improve this? We need to rethink the process. It's not feasible anymore for one scientist to go through all the stages for the large topics that we're dealing with today. Even though that may be ideal from a thinking perspective, but in reality, you have to work together, and you can have people that focus mainly on hypothesis generation and understanding where the field goes and creating consensus. Others that generate the data and only generate data, but generate it in such a way that it can be reused by others that, for instance, only focus on the analysis. There are many bioinformatics labs these days that only analyze public data. And that's possible thanks to through open science, through making all the steps in this process independent to some extent of each other. And that way you get a network, a global network of scientists that can work together. And there's another aspect to this, the societal aspect. It's no longer okay to just be in your ivory tower and do your thing as a scientist, because science and technology is at the very basis of our society. And I'm happy to live in a country where scientists are taking at least the political class makes an effort to take science seriously and to take scientific institution reports seriously when producing policy, such as around COVID. But what is this also raises the bar for those institutions to be very transparent on how they arrive at the conclusions that they arrive at. Because, well, today we directly feel this through the measures that are being taken. All right, so that's the case for open science and why it's so important to share data, to make data fair, to have open access papers, and to make this whole thread transparent. But let's look at some actual examples. And before we do that, just a quick recap. The classical way of doing science, as we saw, it has too many perverse incentives. We can change this by collaborating digitally and exchanging data sets that can be analyzed, changing analysis methods, etc. And that this is not only relevant for science, but also for society. So the example that I want to dive in is the example of medical sciences. Very relevant, certainly to the whole society today in times of a pandemic. So let me first introduce to you the EHDEN project, which is an IMI project in which the Hyve participates along with some other small companies, universities, and also a number of pharma companies. And our goal is to harmonize more than 100 million health records in Europe to the OMOP common data model. I'll come back to that in a second. And the goal is to produce medical evidence. And the way we do that is by establishing self-sustaining open science collaboration. So let's dive a little bit deeper into that. What does that really mean, and how is it different from the classical way of medical evidence generation, where you have some sort of patient level data in your source system, which you then analyze, and you come up with hazard ratios, or you look at effect estimates, and then you publish that and say, hey, look, this is what I found as evidence, and here's how I did it. Well, a key aspect of the OHDSI approach is that we put something in the middle, which is a patient level common data model called OMOP, Observational Medical Outcome Partnership. And in the ideal world, what we would like to do is standardize our methods, standardize our data, and then we could just plug in the methods into the data. The problem today is that the source data often doesn't look like that. And the interoperability through the OMOP common data model tries to address that, so that we can actually use multiple disparate data sources across the world for the same study. Obviously, we also need to standardize our analytics to take advantage of that. We would need to build a data network. And last but not least, we also need a very strong community of people that work together, and that epidemiologists and clinical researchers work together with the computer scientists and the data scientists to make this happen. In EHDEN, we are working on all of that together with the OHDSI community. So if we look at the elements of the OHDSI community that make this happen, as I mentioned before, the common data model is key in this. On the screen, I'm showing a overview of the model. As you can see, it's really person-based. And also all the tables have dates attached to this. So this is really meant for any sort of medical history data, whether it's from EHRs or registries or even biobanks. It could also be clinical trials, although that's not what it was originally designed for. But we're even looking at standardizing that for the possibility of reusing that from an observational research perspective. And another important aspect besides the model, which is really just a syntactic data model, is the semantics. There are more than 100 medical terminologies across the world that are in use, which are mapped in OMOP and in the OHDSI community to a few standardized vocabularies, such as SNOMED CT for diagnosis, LOINC for measurements, and so on. And this is a core asset of the OHDSI community that enables the interoperability and the rapid open science that I'm about to show you some examples of. The last thing, the standardized analytics is actually built up of a number of building blocks to create cohorts, to run effect estimates, for instance, for the efficacy or safety of drugs, but also to do things like patient level prediction, which is given a specific history, medical history, can I predict likely outcomes or things that I have to take into account when making decisions. All right, so OHDSI's been working on this for a while, and this paper from 2016 really was one of the landmark papers where data from more than 250 million patients across the world was shown in one analysis. And this established the feasibility of the approach, more or less. But since then, we also had, for instance, last year, a study on antihypertensive drug classes. And this study actually came in really handy when doing some of the COVID research. But what it was originally about is looking at the adverse effect or adverse outcomes cardiovascular outcomes of certain hypertensive drugs. And it created quite a splash because this was really the first time that this was done in millions of patients across the globe. So then the last example I want to dive into is the COVID-19 studyathon. Going back to where I started, that chaotic period in March this year, where people were searching for answers. What does this disease do? How deadly is it really? But also, what are some of the comorbidities that and possible drug effects that we have to take into account? So at that point in time, the OHDSI community, of course, already had many data sources across the world that had converted their data to OMOP. We also had the analytics established. And we had planned to have a European OHDSI meeting in March, which was all set up. But then the pandemic happened and we made it a virtual event. But more importantly, we changed it to be a studyathon that fully focused on COVID-19, which was, I can say, a resounding success. So we had more than 300 collaborators calling in, and 12 concurrent studies were initiated at that time. So we had and still have data sources across the world with COVID patients that are mapped to OMOP, such as Columbia University in New York and a number of other places in the United States and from Europe and from South Korea, Japan. And using those data sources, we looked at 12 research questions. Some of them actually affect estimations of safety of drugs. And I'll give you an example. I always like it at BioIT World when people show concrete examples of the technologies. After all, it's a tech conference, and I'll do the same as well here. So what I will zoom into is this study that was cited actually by the EMA in guidance and established for the first time in the history, because this generic drug was of interest to the rheumatoid arthritis community, for instance, but of course got a really big podium when, for instance, the US president started talking about it. So in the OHDSI studyathon, what we looked at is what is the safety of the drug? What's the safety profile? And that was never done before in such a large setting with 1 million patients that were taking the drug. And as you can see here, this is an open source tool called Atlas. And in Atlas, I can create cohorts using temporal constraints. For instance, here you can see the definition of a cohort of rheumatoid arthritis patients with the condition. And the OHDSI Atlas tool is perhaps one of the most elaborate tools I've ever seen to create complex temporal constraints on medical data. And it's definitely a core building block of everything that the OHDSI suite allows you to do. So the next step is you can use these cohorts to build inclusion profiles, and of course also look at strata, so stratify that by age and by sex, etc. But also what you can do is use some of these epidemiological building blocks, such as the effect estimations. Here you can see that the target and comparator cohorts for the effect estimations are put in, and of course the outcome cohort, as you would expect. But note that there's also a cohort or number of cohorts here for all analysis, which are used for negative controls. And that's key when you want to calibrate your statistics. In observational data, we can't do randomization, so we have to eliminate sources of variations in our analysis in other ways. And using negative controls is just one of those measures that that are employed for that. All right, so in this case, the self-controlled case series is used, and what behind the scenes Atlas does is actually generating a SQL statement that people can execute on their own data. And that's in general the process that OHDSI network studies such as this one use. The data, the patient level data, doesn't need to leave the hospital, the registry, the health authority, or wherever it's located, but it's converted locally to the OMOP CDM. And then when the study is created and the cohorts are defined and there's consensus on the analysis method and parameters to use, a study package is being generated, put on GitHub, and that package is then executed locally at every site, and the results are uploaded back to a central server. So you can call this a personal health train or a distributed analysis, but however you call it, the result is that you never have to share any patient level data beyond the confines of the institution that's responsible for them, or that's its custodian. But you can still generate evidence at scale, and that evidence is open. So here, for instance, you can see the data website behind the hydroxychloroquine paper, where I can look at all the estimates being generated, and I can see the Kaplan-Meier plots, etc., etc. Break that down by data source. Look at all the analysis that were done. So not just, you know, a few target comparator combinations, but you can put as many as you want and publish them. It's one of the great things of open science, and not only relying on a PDF with pages of tables of supplementary information, but this is actually much nicer to explore. All right, and then within weeks, literally, we had, you can see the date is April 10. We had posted the preprint already on medRxiv. But now the interesting thing is, it's not just the paper, but we also can go back and see that all the analysis, the data, the stratification, as I just showed in the OHDSI data site. All right, so that is my walkthrough of an example of applying the OHDSI network study methods. My key message really is that through these studyathons, and you can actually read up and listen to this more in some of the resources that I linked here, for instance, this webinar. Through this, you can really change the speed of medical evidence generation. Again, some of the resources here are the COVID-19 resources on the OHDSI website, and even we have now produced as a community a book called the Book of OHDSI, which goes in details on the OMOP CDM and how we do network studies. So in conclusion, I hope that I've shown you that medical evidence generation really is changing drastically through open science. The old paradigm of one study, one database, single estimates is passing and will be eventually surpassed by this new method of large-scale systemic evidence generation through open methods and open science. Thank you very much, and I'm happy to answer any questions that come up in the panel after this presentation.